Hello, my name is Arun Roy and today we shall do one of the perhaps most important concepts in stoichiometry, that is equivalent weights. I prefer the word equivalent mass because all those who have done physics, they know mass and weights are not same. I prefer the word equivalent mass. It's a very simple but a very powerful tool for solving problems in chemical equations. Before we go to equivalent mass, I am showing three reactions. I am very sure every student having passed 10th must have heard about these reactions. That is, nitric acid while reacting with metals like copper, zinc, iron. Mostly there are three types of reactions. One with very dilute and cold nitric acid, 50% dilute or 50% concentric and cold, and hot and concentrated. So depending on the state in which nitric acid is and the temperature, we can either get N2O gas or NO or NO2, are very commonly used reactions in books. Why did I choose these reactions? You see that we have same two molecules, zinc and nitric acid, and essentially they are not acting in the same molar ratio, which some students wrongly think to be right. I repeat, or I take a converse case. Mostly I find the students think that if two molecules A and B are to react, the ratio in which A and B react is a constant. They always react in constant ratio. That is not right. Please recall, when you did chemistry or chemical equations in the schools, you might have wrongly interpreted that there is a fixed ratio in which two given molecules react. That is not true. There are many such examples. You must have seen this reaction, ammonia and chlorine. Ammonia and chlorine can react in the ratio 8:3, that is excess of ammonia. The product is ammonium chloride and we get nitrogen. Or when we have chlorine in excess, we get NCl3 and we get HCl. This is an explosive. So ammonia and chlorine also cannot be said to be reacting in a fixed ratio. It is 8:3 here, but 1:3 here. So first I wanted to bring out that apparent myth from the students' minds that molecules always react in a constant ratio. They don't. And because two molecules don't have to essentially react in the same ratio, so I cannot say that 4 molecular mass of zinc here, which is reacting with 10 molecular mass to give one product, always 4 molecular mass will react with 10 moles or molecular mass of nitric acid. So that leads to other problem, that molecular mass also is not something which we can say that a given molecular mass of A will always react with a same molecular mass of B. Am I clear? So the mathematicians who are working in the chemical calculations, or the chemists, they found, or maybe they made a different model, and then they talked about some quantity which they called equivalent mass. About this physical quantity, they said that no matter what the type of reaction, if a substance A has to react with B to give, say, C and D, a given equivalent mass of A, suppose 1, always will react with same equivalent mass of B to give same equivalent mass of C and D, which means one equivalent of A always will react with one equivalent of B to give one equivalent of C and one equivalent of D, whether the reaction is of this type or something like this type. In both the reactions, what is same? If I take a certain gram equivalent of A, certain equivalent mass of A, suppose 5. In this also 5 of A has to react with 5 of B to give 5 of C and 5 of D. And here also if I take 5 of A has to react with 5 of B to give 5 of C and 5 of D. Isn't this very, very convenient to work with? It is. It is. Which means even if I do not know the reaction, in what ratio does the reaction happen, even if I do not know, I just happen to know that somebody says that A reacts with B. I do not know what the reaction is. This information is sufficient numerically. In what way? If I know that we have started with 2 equivalents of A, the end, we can immediately predict that the mass consumed of B also will be 2 equivalent. Suppose somebody tells me in some experimental analysis it was found that substance A reacts with B to give C. I just know that much. I do not know the chemical reaction. Still I can predict that C produced also will be 2 equivalents only. This is the power of the concept which is called equivalent mass. I don't even have to know the reaction. I just need to know they react. So about equivalent mass, before we come to formal definition, we can say that it is a quantity, if I know for either for the reactant or for the product, it is sufficient for me to predict that same quantity will be true for D reactant or a B reactant. I repeat, suppose somebody tells me that ammonia reacts with some unknown molecule whose formula could be, I do not even know the formula. I just need to know ammonia reacts with some molecule X2Y to give some substance Zp. I do not know what is Z and what is P so far. I do not know even the chemical structure of the molecule. I just know that ammonia reacts with this substance A, suppose we call it X2Y, to give Zp. One thing we are sure, and what is one thing we are sure? If I know how much ammonia we have taken, suppose we have taken 3/2 equivalents of ammonia, I have enough information. You can predict what I am going to say. 3/2 equivalents of ammonia has to react with 3/2 equivalents of say X2Y, and amount Zp produced also will be 3/2 equivalents only. Have I reasserted the power of the concept called equivalent mass? Perhaps yes. So let's define that quantity called equivalent mass. The formal definition of equivalent mass is, it is that mass of a substance, say S, which reacts with always 1 gram of hydrogen or replaces 1 gram hydrogen. It reacts with 1 gram hydrogen or produces 1 gram hydrogen. If it is to react with say chlorine, it must react with 35.5 gram chlorine or must produce 35.5 gram chlorine. If it happens to react neither with chlorine or hydrogen but say oxygen, it must react with 16 gram oxygen to produce 16 gram oxygen. But in this case the product must be a peroxide. Mostly it is oxide. In case of oxide, it must be 8 gram oxygen to produce 8 gram peroxide. At the moment we shall not consider these, although they are important. At the moment we say it is that mass of substance which reacts with 1 gram hydrogen. What is so good about 1 gram? Because the starting point is, we assume that equivalent mass of hydrogen is 1 gram. This is the starting point. Why have we done so? I will say just standard. in the previous chapters of moles, we did say that atomic mass of hydrogen being 1 does not mean one atom of hydrogen weighs 1. That 1 was taken almost as an arbitrary standard. So here also as a standard we take equivalent mass of hydrogen is 1. Now I do not have to take any standard, everything else will follow. What is the meaning of everything else will follow? Because equivalent mass of hydrogen is 1, so 1 gram hydrogen will react with any amount of X, that any amount will become equivalent mass of the other substance. We saw some time back, 1 equivalent always reacts with 1 equivalent. So that mass of substance which reacts with 1 gram hydrogen, why will that mass be equivalent mass? Because 1 happens to be the equivalent mass of hydrogen. 1 gram hydrogen is 1 equivalent of hydrogen. So 1 equivalent of hydrogen has to react with 1 equivalent of that mass of that substance. So we revert the definition. We say that equivalent weight of a substance is that mass which reacts with 1 gram hydrogen. Why? Because 1 gram happens to be the equivalent mass of hydrogen. Why chlorine 35.5 is taken? That is something you need not memorize, you can deduce. How can we deduce? All of us know that H2 plus Cl2 is equal to 2HCl. So all of us know that 2 gram hydrogen, 1's atomic mass, 1 multiplied by 2. And 35.5 is the atomic mass, into 2 will become 71, sorry. So 2 gram hydrogen obviously reacts with 71 gram chlorine. So 1 gram hydrogen has to react with 35.5 gram chlorine. Am I clear? Now, what is so special about 1 gram? It also happens to be the equivalent mass of hydrogen. So 1 equivalent mass of hydrogen has to react with 1 equivalent mass of chlorine. That number has to be 35.5. That number happens to be 35.5. So equivalent mass of chlorine becomes now 35.5. Am I clear? So we conclude that this 35.5 also is a special number. It happens to be the equivalent mass of chlorine. Those who are slightly confused that it also happens to be the atomic mass, it's just a chance. And it's true. But at the moment 35.5 with regards to chlorine represents to its equivalent mass. It also represents atomic mass. At this point of time we are not concerned about that. So why did we extend the list from hydrogen to chlorine? Because equivalent mass of chlorine is 35.5. For oxygen we took 2 numbers. It is obvious because hydrogen reacts with oxygen to give H2O2 also, and hydrogen also reacts with oxygen to give H2O, all of us know. So when it is a matter of peroxide, let us only concentrate there. When it is a matter of peroxide, what do we see? We see 1 into 2, 2 grams hydrogen is reacting with 16 into 2, 32 grams oxygen. Equivalent mass of hydrogen is 1. So whatever mass of oxygen reacts with 1 gram hydrogen will become the equivalent mass of oxygen. Let us see. How much mass of oxygen is reacting with 1 gram hydrogen? 16. So 16 becomes the equivalent mass of oxygen when the product is peroxide. When the product is peroxide. So because 16 gram happens to be the equivalent mass of peroxide, so when it is a formation of peroxide, that mass of the substance which reacts with 16 gram oxygen to form a peroxide, that will become the equivalent mass of that substance. Are you getting the point? Sodium reacts with oxygen to give sodium peroxide by this reaction. Suppose for sake of discussion we did not know that sodium reacts with chlorine. Suppose we did not know that sodium reacts with hydrogen. Go back in the history of time. Suppose we knew sodium only reacts with oxygen to give peroxide as per this equation. I do not know the equivalent mass of sodium. How do you find out? I do know the equivalent mass of oxygen when the formation is peroxide. How much it is? 16 grams. So simple. What do? I find that mass of sodium which reacts with 16 gram oxygen. What is that mass? Obviously, again 32 grams, 16 into 2 reacts with 2 into 23. If you recall, atomic mass of sodium is 23. So 32 grams sodium, please forgive me, 32 gram oxygen reacts with 2 into 23 gram sodium. So 16 will react with 23 gram sodium. So equivalent mass of sodium becomes 23. Am I clear? But when the formation is oxide, then again we know the famous reaction 2H2 plus O2 is equal to 2H2O. This is an oxide. Here we see that 32 grams of sodium are reacting with 4 grams hydrogen. The equivalent mass of hydrogen is constant, it's always 1. Because one equivalent always reacts with one equivalent. So one equivalent of hydrogen will always react with one equivalent of oxygen. What is the one equivalent of hydrogen? Answer 1. So we have to see how many grams of oxygen are reacting with 1 gram of sodium. Please forgive me, 1 gram of hydrogen. So what do we see? 4 reacts with 32, so 1 will react with 8. So 1 gram of hydrogen, which happens to be the equivalent mass of hydrogen, reacts with 8 gram oxygen, so 8 will become the equivalent mass of oxygen. So from here we also deduce that equivalent mass of oxygen is 8 when the formation involves oxide, and equivalent mass of oxygen is 16 when the formation involves peroxide. Could we have prolonged the list? Of course, yes. So if the books stop here, you don't have to stop here. You can write your own book and add more atoms. Only thing to be assured of is that when we are adding the atom, here must come the equivalent mass of that atom. Am I clear? Because one equivalent always reacts with one equivalent. Some time back we saw equivalent mass of sodium is 23. You can definitely extend the definition here. That is, equivalent mass of substance is that mass of the substance which reacts with 23 gram sodium. So this is what we call the definition of equivalent mass. The definition also derives from the concept that one equivalent always reacts with one equivalent. No matter what the type of reaction, what the condition of reaction, what the product of reaction, what the ratio of the reaction, irrespective of that, one equivalent always will react with one equivalent. This is the power of equivalent mass. So having discussed that, naturally it is important, looking at the list also, that we know how to find the equivalent mass of a given substance. Okay. So we start with how many types of substances normally do we come across? We come across atoms, we come across ions, we come across salts. I wrote ions before salts because salts are nothing but the combination of ions. Ions are A and B minus, etc. Salt will be A plus plus B minus. So if I know the equivalent mass of ion, automatically I can find that of a salt also. But presently we have atoms, we have ions, we have salts, we have acids, we have bases. So if I teach you how to find the equivalent mass of an atom or an ion or a salt or acid or base, so virtually you have a very powerful tool with you about that substance, be it ion or molecule or an atom. What do we know? We know its equivalent mass. That mere information makes further calculations very, very simple. How? We already have discussed it. So what should be the idea now? Idea should be now to find the equivalent mass of, say, beginning with atoms. So usually when we have an atom, we divide the atomic mass of the atom with its valency. Very simple. So equivalent mass of an atom will be its atomic mass by valency. Some time back we found for sodium its equivalent mass also was 23. Its atomic mass is 23, but valency is 1. So in this case, in the case of sodium, or in case of hydrogen also, atomic mass of hydrogen is 1, its valency is 1, so equivalent mass also became 1. Chlorine atomic mass is 35.5 and valency of chlorine is 1, so equivalent mass also becomes 35.5. So it was not surprising that in some cases we found that atomic mass and equivalent mass were same. Converse question, when will they be same? Obviously when the valency of the substance is, of the atom is 1. What will be atomic mass of aluminium? I want to know the atomic mass of, please forgive me, what will be equivalent mass of aluminium? All of us know atomic mass of aluminium is 23. Valency of aluminium is 3. So equivalent mass of aluminium will be 23 by 3. Approximately 7 point something. Are you clear now? How do you find the equivalent mass of iron? Now it is slightly involved question. Iron shows 2 valencies. 2 also, 3 also. So equivalent mass of iron will be 56 by 2 in some cases and 56 by 3 in some cases. Which cases? Sometimes iron will react, say, with oxygen to give FeO, and sometimes you know iron reacts with oxygen to give Fe2O3. So obviously in this reaction equivalent weight of iron will be 56 by 2, but in this case it will be 56 by 3. So I just want to keep one option open, that valency of the atom does decide the equivalent mass. So what can we say? If the valency of the equivalent mass, please forgive me, if the valency of the atom is fixed, its equivalent weight becomes fixed, that is atomic mass by valency. Or also we can say the atoms which do not show any change in the valencies, their equivalent masses also remain same, atomic mass by the valency. Calcium will have always a constant equivalent mass, because calcium's atomic mass is 20, its valency always is 2, so equivalent mass of calcium always will be 20. Sodium always 23, potassium always 39. Am I clear? Magnesium always 24. So we know how to find out the equivalent mass of atoms. Now how do we find the equivalent mass of ions? This is also very, very simple. Ions will have some charge. Phosphate will have charge minus, minus, minus. Chloride has a charge minus. Sulfate has minus, minus, etc. So equivalent mass of ion will be, calculate the molecular mass divided by the charge, simple, divided by the charge or number of charges. Number of charges. For example, phosphate. What will be equivalent mass of phosphate? What do I need to find out? Molecular mass of phosphate. What will be molecular mass? Phosphorus is 31, O is 16 into 464 divided by 3 charges, 3. Simple. Am I clear? What will be equivalent mass of sulfate? Equivalent mass of sulfate will be, it's laughably simple, you can predict. Molecular mass of sulfate. Molecular mass, sulfur is 32, O 64 into 4, 64. How many charges? 2, divided by 2. So for ions, we can find the equivalent mass by dividing the molecular mass by the number of charges. Suppose we have a slightly complex looking ion, something like Ag, NH3, whole twice plus this is anion. What will be its equivalent mass? The formula remains same. Molecular mass, silver all of us know is 108 plus nitrogen is 14 into 2, 28, 1 into 3 into 2 plus 6. So this is the molar mass of AgNH3 whole twice. How much charge? 1. So in this case again molar mass will be same as equivalent mass. Am I clear? So we have got the equivalent mass of ions. Now salts, that is still very simple. How to find the equivalent mass of a salt? It's very simple. Every salt has a cation plus charge and an anion minus charge. We know that. Every salt will be made up of a certain cation and certain anion. Equivalent mass of the salt simply will be sum of equivalent mass of cation plus equivalent mass of anion. Very simple. Warning, please take note of this. Do not multiply this by number of cations if it is more than 1. So this expression is independent of how many cations or how many anions are there. Number of cations or number of anions do not matter here. By here I mean calculation of equivalent mass. Okay. Example. I want to find the equivalent mass of calcium phosphate. What does the expression say? It will be equal to equivalent mass of calcium plus equivalent mass of phosphate. Warning, I am not multiplying by 3 just because these 3 and 2 at the moment are of no use. At the moment they do not play any role here. Be very careful about it. It will be just equivalent mass of calcium. Now what is the equivalent mass of an ion? Molecular mass, calcium is 40, so becomes 40, divided by charge, number of charges 2. Phosphate, again molecular mass by charge is 3, molecular mass 31 plus 16 4 ja 64. This will be the equivalent mass of calcium phosphate. The numbers 3 and 2 do not play a role here. Just that of cation plus that of anion. How to find that of the cation? Molecular mass by number of charges, molecular mass by number of charges. Okay. We'll take one more example. There is a slightly complex looking molecule which I am very sure you must have come across. Potassium ferrocyanide. I want to find the equivalent mass of potassium ferrocyanide. Must have heard about this molecule in the school. K4 FeCN whole 6. Let's put it a small bracket here and a large bracket here. I want to find the equivalent mass. One thing is sure, it is not an atom, it is a salt. So what do we do? In case of salt, we break up into cations and anions. Numbers are not important. So what is the cation here? Potassium plus. This 4 is not important. And ferrocyanide is an ion. If you do not know it now. Ferrocyanide by itself is an ion with 4 negative charges. This is called ferrocyanide ion. So potassium plus is the cation and ferrocyanide is the anion. This 4 doesn't play a role. Here 6 was not the number of the ions. This was a part of the formula of the anion. Anion is this. Here 4 was not part of the cation. There are 4 cations. So I do not concern with how many cations are there. But there is only one anion, namely ferrocyanide. So rest is simple. What is the equivalent mass of potassium ion? And atomic mass in this case will be same as molecular mass, 39. What is the charge on potassium? +1. So 39 by 1 will be the equivalent mass of potassium. What about cyanide? Same formula, molecular mass. What is molecular mass? Iron, if you know, is 56. Carbon is 12. Nitrogen is 14. The sum becomes 36 into 6 because there are 6 such cases. So this is the molecular mass of entire ferrocyanide. How many charges are there? 4. I might ask that again, sign of the charge does not decide whether plus or we are not talking about the sign, only the number. So this 3 minus or 4 minus does not come into picture, only the number. So this is the equivalent mass of potassium ferrocyanide. Am I clear? So of the atom, atomic mass by valency. Of the ion, molecular mass by charge, only the value of charge, not plus or minus. Of a salt, sum of equivalent mass of cation plus equivalent mass of anion. So we have done atoms, we have done molecules, we have done salts. Now we come to acids. Okay, acids. Before we talk about acids, I am very sure you might have heard about the word basicity. The word basicity is only associated with the term acid. So we have basicity of an acid. In schools, when the discussion was not very involved, how did we decide the basicity of an acid? For that, you took an acid, maybe HCl, maybe H2SO4, maybe H3PO4. We reacted the acid with a monobasic acid like NaOH. At the moment, we shall not talk about mono acidity of base. It will become clear. Just have some patience. Just have a starting point. NaOH or QOH are called mono acidic bases. So if I react HCl with QOH or HCl with NaOH, we say that the reaction goes like this. Haven't you seen that? But if you react sulfuric acid with NaOH, we require 2 moles of NaOH to give Na2SO4 and H2O and 2H2O. But when we react H3PO4, we require 3 NaOH to give what? Sodium phosphate and water. So the schools must have taught you basicity of an acid is the number of moles of the monobasic acid with which 1 mole of the acid reacts. So here 1 mole reacts with 1 mole of NaOH. So basicity of HCl is 1. Here 1 mole of sulfuric acid reacts with 2 moles of NaOH. So basicity of sulfuric acid is 2. And by the same logic, basicity of phosphoric acid is 3. This is what must have been discussed in the class, which was not wrong, completely right. But sometimes it is not very easy to find out through a reaction with how many moles of a monoacidic base will it react. So what we do here, we know that an acid gives protons. That is, this was the earlier definition of acid. Nowadays we do not stick to that, but it is not wrong that acid does give protons also. The number of protons an acid can give, the number of protons an acid can give decides the basicity of an acid. But before I start, here I am assuming that the acids which we are taking, they are hydra acids, which means they essentially have hydrogen. Molecules like SO2 also are acidic, but they don't contain hydrogen. They don't give protons directly. So my discussion at this point is only based on those acids which are hydra acids, or which have got replaceable hydrogen atom and which can go out in the form of a proton. Very, very important. So at the moment when we are talking about only those acids from which hydrogen can be replaced, no, not only that, and the replaced hydrogen should go out should be capable of going out in the form of proton. We can replace hydrogen from ammonia. Yes or no? If no, probably you have not seen that reaction. Sodium or potassium react with ammonia to give amides. Amides are NH2s. Sodium amide. If you have taken potassium, potassium amide. So amides are NH2 group. Plus we get hydrogen. Plus we get hydrogen. So go slowly. Hydrogen is being replaced from ammonia by sodium. Sodium is replacing H. H is going out. Does that make ammonia an acid? No, because I did not say the molecule must contain replaceable hydrogen atom. I said the replaceable hydrogen atom should be coming out as a proton. This hydrogen is not coming out as a proton. So only replaceability of hydrogen is not sufficient criteria. From methane, I can replace the hydrogen by chlorine like this. Chlorine is replacing hydrogen, but hydrogen coming out is not in the form of proton. So what is it I am saying? We are talking about only those acids from which hydrogen can come out as a proton. For such acids, the number of protons which can come out decide the basicity of the acid. The number of protons which can come out of the acid, or which are coming out in the particular reaction, they decide the basicity of an acid. Some acids can give only one proton, so they are called mono. Mono means single, one. Monoprotic. Big word, doesn't have much of a difficulty if you understand. Mono means single, one. So HCl is an example of monoprotic acid. Nitric acid is an example of monoprotic acid, which it cannot give more than one proton. Sulfuric acid, however, now it's simple. It's coming out to be very, very simple. Sulfuric acid can give two protons. If it breaks, it can give two protons and SO4 minus minus. So how do we decide sulfuric acid in this notation? It is a diprotic acid. And exactly, so what will be the basicity of sulfuric acid? It will be 2. Phosphoric acid, exactly by the same discussion, can give 3 protons. So it is triprotic. So the basicity of phosphoric acid will be 3. So I have been able to explain what do we mean by basicity of an acid. Basicity of an acid, if the acid is containing hydrogen which can come out as a proton, in that case basicity is just equal to number of protons coming out of the acid. Am I clear? For monobasic acids, there is no problem. Monobasic acid always will give or can give only one proton. They are monoprotic. They are monobasic. So their basicity always will be 1. But please concentrate. In case of diprotic acids, it so happens that in one stage of a reaction only one proton comes out, and you must have definitely seen certain reactions. Sulfuric acid can dissociate as one proton and bisulfate. Example, when sulfuric acid reacts with NaOH in such a way that first product is NaHSO4 plus water. Here obviously bisulfate has come, which means only one hydrogen was involved. Only one hydrogen came as proton. When we have excess of NaOH, all of you know what happens. We get Na2SO4 plus H2H2O. In that case, we have got sulfate. When does sulfuric acid to dissociate to give sulfate? When it is releasing or liberating 2 protons. So a dibasic acid or a diprotic acid can liberate 1 proton also, can liberate 2 protons also. Accordingly, its equivalent mass changes. Accordingly, it has 2 different values of equivalent mass. Basic concept is same. How many protons are coming out? Because in such cases, 1 proton can come out or both the protons can come out. So in such cases, the equivalent mass becomes molar mass. Equivalent mass becomes molar mass by the basicity, which can be 1 or which can be 2. So this is the definition of equivalent mass for acids. It is molar mass by basicity. In case of monoprotic acids, HCl, HNO3, it will always be equal to molecular mass because basicity in this case always will be 1. But in case of dibasic acids, it can be molar mass by 1 or molar mass by 2. So what is the equivalent mass of sulfuric acid in this reaction? They will never ask you what is the equivalent mass of HCl in this reaction. In all reactions it will be molecular mass by 1 because basicity is 1. But in case of sulfuric acid or maybe phosphoric acid, you have to carefully look at the reaction in which you want to involve the concept of equivalent mass. What should you look for in the reaction? How many protons are getting involved? So equivalent mass of sulfuric acid in the reaction number 1 will be equal to its molar mass, which is 98 by 1. But in this reaction it will be molecular mass, which is 98 by 2, because 2 protons are coming, 49. So sulfuric acid can have equivalent mass 49 or 98 depending on 1 proton is involved or 2 protons are involved. And exactly by the same logic, if I just say find the equivalent mass of phosphoric acid, it is better to look at the reaction where it is reacting. If phosphoric acid is reacting like this, where we shall have Na2HPO4 plus H2O, then we are saying that H3PO4, from H3PO4 what is coming out is HPO4, which charge is minus. So only 2 protons must have come out, which is not difficult to understand. 2 protons must have been replaced by 2 sodium ions. So in this reaction, because we have HPO4 minus coming out as an acid radical, means only 2 protons must have involved. So here the equivalent mass of H3PO4 will be its molecular mass 3 plus 31 plus 16 4 the 64 divided by 2, that is 98 by 2. It is just a chance. Sulfuric acid and phosphoric acid have same molar mass 98. Phosphoric acid and sulfuric acid have same molar mass 98. So in this reaction its equivalent mass will be 98 by 2. Am I clear? Exactly similarly we talk about equivalent masses of bases. For bases we have a term called acidity. So when we use the word acidity, it is always associated with a base. Accordingly, the bases can be monoacidic. Here one check is, it depends on the number of hydroxyl ions. NaOH, KOH, they have only one hydroxyl ion. So they will be attached to only one proton, so their acidity always will be 1. So acidic base, for them the equivalent mass will be molar mass by 1, because acidity of such bases is 1. But if you have calcium hydroxide or magnesium hydroxide, it becomes now simple to anticipate. Here there are 2 hydroxyl ions, so they can react with 2 protons. So their acidity will be 2, because they will react with 2 protons. So in such cases, equivalent mass will be molar mass by 2. Am I clear? Again, only in case of diacidic base. It is possible that only one OH comes out, one does not come out. It is possible. Do you recall the formation of bleaching powder? In class 9th, 10th you must have done. How do we produce bleaching powder? We pass chlorine in lime water, calcium hydroxide. Bleaching powder is best described as CaOCl, cut. Start. Please remove the part of bleaching powder. You must have heard about the fact that magnesium hydroxide, if you have not heard, hear it now, when it reacts with chlorine, the first product is magnesium hydroxychloride. Magnesium hydroxychloride. I'll give you one more example of a reaction when this molecule is produced. When you heat magnesium chloride, it absorbs some moisture or it reacts with water, and it gives magnesium hydroxychloride. So when the magnesium hydroxychloride was produced, obviously only one hydroxyl was replaced, other hydroxyl remained with magnesium. This example has got nothing to do with acid or base. Just to make you realize or make you remember, have you heard a compound of a similar nature? Or if not, you have heard it now. I am again giving you a general knowledge. Why it is not possible to produce an anhydrous sample of magnesium chloride just by heating hydrous sample of magnesium chloride. Does it ring some bell? Some molecules have got water of crystallization attached to them. Like copper sulfate has got 5 molecules. Calcium chloride actually has 6 molecules. How do you make the dry sample? Simple, simply by heating. Simply by heat to maybe 230 degrees centigrade, the sample containing water becomes a dry. This is also called anhydrous. So calcium chloride, whose hydrous sample is this, if you heat to a larger extent, it becomes a dry. This is called anhydrous or dry sample. You cannot create a dry sample of magnesium chloride just by heating the hydrous sample. Why? You cannot do that, unlike others. Answer is this, that actually magnesium chloride contains 6 molecules of water. When you heat very hard, 5 molecules leave the main sample, 1 still remains there. So what do? Heat this harder to remove the water. In this case, not in many cases, in this case, even if you hit the molecule harder, this water molecule does not go out. Actually, it decomposes the molecule. It reacts with MgCl2, and the reaction product is one OH comes here from water, one OH comes here, remaining hydrogen and remaining chlorine became HCl. We get magnesium hydroxychloride. So I give all these many examples of general knowledge that in some cases both the hydroxyls need not go away. In case of magnesium, both are not going away. Are you clear? If not, as I keep on repeating, please watch the video again, because whenever some extra information comes, it's most welcome. So please watch it again. The main purpose of talking 2 or 3 times in the same case is that from certain hydroxyl samples, more than 2 or 2, sometimes it happens one hydroxy sample remains in the molecule. So these examples were just to illustrate such cases. But it's a very important general knowledge information. You cannot get a dry sample of magnesium chloride by heating the wet sample. So if you want to get a dry sample, there are other methods. We shall not talk about them right now. I wanted to talk about the existence of molecule like magnesium hydroxychloride. So if I have a base magnesium hydroxide, if I react with HCl, is there a possibility of producing this kind of a molecule or no? Of course, yes, there is a possibility. We just saw it. If it happens, here what will be the equivalent mass of magnesium hydroxide? Here, out of 2 hydroxyl groups, only one has come out. Only one came out. That one coming out reacted with H plus to give water. Other hydroxyl remained in the molecule. So here the acidity of magnesium hydroxide is 1, because one mole is reacting only with the 1 mole of HCl. So its acidity is 1. So its equivalent mass will be divided by 1. What will be mass? Magnesium 24, O16 plus 1 17, 17 2s are 34. Description is exactly same as that of the acid. So equivalent mass of an acid will be molar mass by basicity or number of protons involved in the reaction. Equivalent mass of a base will be molecular mass by acidity or number of hydroxyl groups associated. Okay. And this discussion I am again saying that it confines to the molecules containing hydrogen, which can go as proton, or hydroxyl ion, which can come out. About some other acids which are not having hydrogen, we shall discuss it later on. So basically, if you realize, we have discussed how to find the equivalent mass of different types of molecules that you will encounter while the discussions of chemical calculation. Atom, atomic mass by valency. What about ion? Ion, molecular mass by charge. Mass by charge. Nature of charge plus or minus is not relevant. Salt, simply equivalent mass of cation plus equivalent mass of anion. There can be more than one plus also. I am just saying cation. Here we do not consider the number of cations or number of anions. Number of cations or number of anions, cations or anions is not to be considered here. And then we talked about acid. Equivalent mass of an acid will be molecular mass by basicity, number of protons involved. And last but not the least, equivalent mass of bases, molecular mass by acidity or number of hydroxyl ions involved. Okay. Thank you. We shall do the next part next time.